Hello, Honors Chemistry. Welcome to lab number 15, Types of Chemical Reactions. In this laboratory, you're going to spend some time with seven different types of chemical reactions in an effort for you to understand and see examples of things like synthesis reactions, decomposition, single replacement, double replacement, and combustion. Each of the reactions detailed in the list below will give you some practice in identifying and seeing those different types of reactions. If you look at your list of equipment and materials, many of these things right here you're going to find in the cabinets at the ends of your lab benches. You might find things like test tubes and the watch glasses at the ends of your countertops, your lab benches. The rest of the materials, things like this list over here to the right, this is in the red plastic holders that are on the lab bench tops for you to share with the lab group next to you. If you need something else that is not in your cabinets and it's on the list, let me know. I'd be happy to get it for you. As you look at the list of procedural steps, it looks pretty detailed. It goes all the way up to 7 different separate reactions. It is not critical that you do these in order. I don't often say that in a lab, but you do not have to do 1 first, then 2 and 3 and so on. You can do these in any order you wish. And I say that because if you're sharing materials, you're sharing reactants, you might need to skip one of these and go to the next one. So feel free to do them in any order. Notice that as they're listed 1 through 7, that correlates with the data table. So the reaction, the procedure step 1 is right here, zinc and copper sulfate. For 2, it's copper and oxygen, and so on. So those go in order. Make sure you use your data table appropriately as you work through this. So a few notes to keep track of here. You definitely want to do step 1 first. And the reason I say that is because you're going to set it aside once you mix the copper sulfate and the zinc filings. Once you mix them together, you're going to set them aside so that at the end of the lab, you're going to return to make more observations. Now, the key to this lab, no matter what step you do, is that you make some initial observations, and then you cause a reaction to happen, and then you make some final observations. And since that's what we're looking for, your data table is set up that way. So don't worry about this first column right now. You can do that later. You'll have better experience at identifying types of reactions. But for right now, you're going to want to make your initial observations of what you see. What does the zinc look like? What does the copper sulfate look like before the reaction? Then mix the reactants together, and then anything you observe happening during or after the reaction, you're going to write in the last column. So for procedure number 1, you're going to first make your observations, mix the two together in a test tube, and then come back later at the end of the lab. It will remind you of that. As you continue, you can move on straight to number 2. I am telling you right now, you can eliminate this first part of step 2. You do not have to sand the copper wire. It's all shiny and new. Just go ahead, observe, record, and do what it asks you to do. For procedure 3, you're going to need some copper carbonate into a clean, dry test tube. Okay, so here is your test tube, into which you're going to put a little bit of copper carbonate in the bottom, and you're going to make some observations, and then you're going to heat the copper carbonate strongly into a burner flame for about a minute. When you heat this copper carbonate in a flame, do make sure that it is not aimed at anyone. Make sure you're not looking at the open end of the test tube, that it's not pointed at your partner. You want to make sure that end of that test tube, and ideally what you want to do is have that test tube at an angle. So you kind of are going to need to hold this with test tube holder at an angle and move that test tube back and forth over the heat so that all the copper carbonate in here gets heated up nice and hot. And then once you extinguish the burner, you're going to insert a burning splint, a wooden splint, into the test tube. but do not drop it into the tube. Make observations about what happens to the burning splint when you insert it into the mouth of the test tube. And once that's cool, that can go into the trash can. Step 4 is magnesium ribbon. That's pretty straightforward. You're going to take the magnesium, you're going to put it into the hottest part of the burner flame, and check out what happens. Do not look directly at the burning magnesium. Do not look at it. It's going to be super bright. You don't want to damage your eyes. So look to the side. Don't look directly at it. Step 5, you're going to be putting together some HCl together with zinc into the test tube. You've done something similar in a lab not too long ago, because then what you're going to do is take a second test tube and you're going to place it atop the zinc and it's not vinegar that you're using HCl. And you're going to be collecting the gas in the top test tube, because then once you've collected it after a minute or two, then you're going to insert the burning splint into the upper test tube. So this test tube is now this test tube. Do the burning splint test and make your observations. In step 6, you're going to need a watch glass, and you're going to mix 5 drops of zinc acetate and 5 drops of sodium phosphate. That's pretty straightforward. It helps to observe the watch glass on the countertop, on the bench top, because what you see when you mix those two solutions, you'll be able to see it if your bench top is dark. It's better to see that on a dark surface than a light one. And the last one, step 7, you're going to put 20 drops of sodium sulfite into a test tube and add some HCl. Throughout this lab, you're using 6 molar HCl. I need to caution you, 6 molar HCl is very strong. If you spill any on you or the lab bench, let me know so that I can clean it up. Once you reach the end and have done all 7 reactions, return to the reaction from step 1 to do some final observations. When you're done, all of the test tubes that have liquids can go down the drain. The solids must go into a trash can. You're going to scrub up those test tubes and invert them into a test tube rack or hang them up to dry for the next class. Good luck, be safe, see you in lab.